Now we have enough information to answer the last part of the question that we were working on in the last video. So I have the same problem. We made a Taylor series in the last video for f of x by combining a Taylor series for sine of x squared and cosine of x. And now we've been asked if p sub 4 of x is the fourth degree Taylor polynomial for x about x equals 0. Use information from this graph of the fifth derivative of x to show that, ooh, that looks kind of scary. What that means is, that says the absolute value of the difference between the fourth degree Taylor polynomial evaluated at x equals 1/4 and the actual value of f at 1/4. So they're asking us to find an upper bound for the error. This is the difference between our approximation, which is p, and the real value, which is f. And they're asking us to do something to prove that we can get that error down to less than 1 in 3,000. Okay, so let's write up the error form again. All right, so this is the form. It's called the Lagrange form of the error bound. So what it says is missing a absolute value bar. So a bound on the error is less than or equal to the m, whatever m is, divided by n plus 1 factorial times the absolute value of x minus a raised to the n plus 1. So we've been told we're supposed to use the fourth degree Taylor polynomial. That tells me that n in this case equals 4. A is 0 because we've been told our Taylor series was formed about x equals 0, so a is 0. And x is the value we want to plug in and find a value of f for. So we were trying to find f of 1/4. That means in this case, at the end, we're going to want to plug in 1/4 for x. So that tells me that when I go to figure out what m is the maximum value of the n plus 1th derivative on the interval 0 to 0, because that's a, to that number I wanted to plug in, so x equals 1/4. That's why they've given us the picture of the fifth derivative of x, fifth derivative of f. Okay, so here's what we want to do. We want to come to this picture and we say, okay, this is the fifth derivative of f. I am interested to know what the biggest value of this derivative is on the interval from 0, which is here, to 1/4. So I have to stop and I have to figure out where x equals 1/4 is on this graph. Well, here's 1, and this is split into 1, 2, 3, 4 sections. So this here represents x equals 1/4. And I have to try to sort of figure out what the maximum value of this fifth derivative is anywhere on this interval. Well, on this interval, the fifth derivative does increase. You can see this is increasing. So I want to pick a y value that's somewhere near, well, the furthest right y value on that interval. So they're not going to mess with you too much. I can say, well, I'm 100% certain that on the interval x is between 0 and 1/4, that fifth derivative never, ever, ever, ever gets to 40. It's a little bit under 40 the whole time. So that's what I'm going to choose. I'm going to say that the fifth derivative of the maximum between 0 and 1/4 of the fifth derivative of x it's definitely less than 40. So if I pick a number that's a little too big, that's okay. I don't want to pick a number that's too small. That'll throw off my inequality. So now I'm going to use some of those numbers. I know the absolute value of my error is going to be less than or equal to, I said I'm going to use 40 for my m. N is 4, So n plus 1 is 5. This is going to be 5 factorial. And x minus a, remember a is 0, and the thing I want to plug in for x is 1/4. This is going to be 1/4 to the n plus 1 is 5. So I know my error is less than, and then I'm just going to do enough algebra to prove what they wanted, which is that this is going to be less than 1/3000th. So I'm just sort of pretend I put that in parentheses because that's how much I just want to simplify enough to get down to this. All right, let's go back to blue. That's less than or equal to 5 factorial is 120, so this is 1/3 times 1/4 to the 5th. This is going to be 1/4 to the 4th is 256 times 4. So I could say something like r sub x, my error is less than or equal to 250 times 4 would be 1,000. So 256 times 4 is more than 1,000. And 3 times something more than 1,000. So you could do the math out, or you could just do sort of approximations like this. This is going to be 3 times, we could say a bunch of different ways to do this, times 256 times 4 is less than 1/3000, because this denominator is going to be bigger than 3,000, so that means that whole fraction must be less than 1/3000. That would be my answer here.